Yeah, we're going to run through some quick vocabulary here for the 3D figures unit. It's probably mostly a refresher, but it's important to review. So the first type of 3D figure that we'll talk about are prisms. And what prisms are is they are, if we have a geometric shape, so here we have a rectangle, and then we have another rectangle that's congruent to it. These are called bases. So what a prism is it takes two geometric shapes that are congruent. We call those the bases, and then they are connected three-dimensionally here. So there's some distance between them, and they create what you probably know as a rectangular prism. Similarly, over here we have these bases that are triangles. And if we take these two triangles that are congruent and we give them some depth and connect them like this with these lines, we now have a triangular prism. And again, these triangles are the bases. So prisms are going to have bases. The bases are going to be the shapes, so we can have a pentagonal prism with pentagons as the bases. We could have a hexagonal prism with a hexagon as the bases. These are the two that we're going to be most used to seeing for our purposes. And then these bases, or these prisms, have a height. So that is the distance between the two bases. So in this triangular case, the height is how long that line is. In this rectangular case, the height is how long that line is. And we're going to use these dimensions to find surface area and volume, which we'll talk about in the next video. Another 3D figure we'll see a lot is a cylinder. A cylinder has two bases, just like a prism does. The bases of a cylinder are circles. And of course these circles have a radius, r, and the radius for both of the bases will be the same. We could also talk about the diameter, which is 2 times the radius. Cylinder is also going to have a height, and similar to a prism, the height is the distance between the two bases. So sometimes you'll see these cylinders turned over on their side. The height is always the distance between the two bases. It doesn't matter if it's going up or down. It's just how far apart those two circles are. Same thing with the prisms. Cone is going to have a radius, just like a cylinder. And of course, if we double the radius, that'll be the diameter. The base of the cone is a circle. It only has one base, as you can see. And then there's the height of the cone is if we go from the tip of the cone down to the center of the base, perpendicular. So perpendicular, remember, means it makes a right angle. That's the height of the cone. And then we also have a distance that we like to measure and that we'll need to find things out about the cone, and that's the distance from the tip of the cone down this side to the base. And it's usually labeled with the letter L, so we'll just talk about it as a length from the tip of the cone all the way down to the base. And it's slanted. It's a slanted measurement, which is usually why we call it slant height. We also have pyramids. So in this case, this is a square pyramid because the base, this bottom shape, is a square. And the pyramid's going to have a height and then a length from the tip to the base, just like we had in a cone. So the height is going to start at the point up top here, going to come down to the center of the base, perpendicular, and that is the height of the pyramid. We also have this length from the top of the pyramid down the side of the pyramid. And we'll usually label that with an L. And if you notice, this exists too in a cone. I have one line here in red, that's the height, one line here in blue, that's the length from the tip to the edge of the base. If I draw a third line in here, I have now created a right triangle. So if you have any of these two dimensions and you need the third one, you can use Pythagorean theorem. So you thought you got away from triangles, but you didn't. The last figure we're going to talk about is a sphere. And a sphere's dimensions, actually there's only one dimension, there's the radius. And this is the radius if we cut the sphere right through the middle. So this is sort of like if we were to chop this sphere in half, that's where we would measure the radius of the sphere. And that radius is going to help us find surface area and volume. Now hopefully most of this was a refresher. It was important to talk about the types of dimensions that these figures have so that we can find surface area and we can find volume, and we'll do that in the next couple videos. There is no you try for you to do, it's just important to have this information.